Okay, the video seems to be working just fine, thank goodness. So moving on, 412. They give us this little expression. They say, hey, plug in let x equal -2, let y equal -3, clean it up. Okay, so 3x squared, so x is -2, squared minus 2. X is -2, y is -3, plus 4, and then y squared, y is -3, squared. Okie doke. So that's a 3. -2 squared would give us a 4. Minus, minus, minus. You see how there's 3? An odd number of negatives? So it's going to be minus 2, 2, 3. 2 times 2 is 4 times 3 is 12, so minus 12. Plus 4. A negative squared is positive. Okay, 3 times 4 is 12. Minus 12. Plus 36. Go from left to right. 12 minus 12 is 0, plus 36. Boom, 36. Okay, 414. The difference of 17 and -8. The difference of 17 and -8. Subtract 17 from the difference. The difference? The difference of 17. So the difference means subtract something. So the difference between 17 and -8. The difference of these two things, 17 and -8. Okay, so 17 plus 8, 25. Okay, B, that was part A. Part B says subtract 17 from -25. So here's -25, and you're going to subtract 17 from that. Subtract 17 from that. So the wording's always a little bit confusing. Just read it a few times. So -25 minus 17. So what is that? -25 minus 17. Calculator. -42. Okie dokie. 416. Simplify. Okay. Save some paper. Try to save some paper. 416. Oh gosh. 204 divided by 228. Well, they're both even, so 2 comes out of them. So if I take out a 2, so 204 divided by 2 is 102. And then 228 divided by 2 is 114. Oh, they're still both even. Okay, so 102 divided by 2 is 51. Ugh. And then 114 divided by 2 is 57. Oh gosh. 51 over 57. Okay, so it's not even, so there's no more 2's. And then how do you know if 3 goes into something? If you add them up and it's divisible by 3, that means 3 goes in. So 5 plus 1 is 6. 3 goes into 6. Okay. 5 plus 7 is 12. And 3 goes into 12. Okay, so 3 goes into each of those. So calculator, 51 divided by 3. So 3 goes in 17 times, and then 57 divided by 3, 19. And now I'm familiar with 17 and 19, and those are both prime numbers, so we're done. Oh, my lordy. 418. Negative 14 over 15 times 10 over 21. A couple ways you can do this problem. You could just multiply across, and then reduce it like we did up here in 416. But the goal is to save time in life. So you want to reduce things as soon as possible. See the 10 and the 15? The 10's on top, the 15's on bottom. These guys are being multiplied. So 5 goes into 10 twice. 5 goes into 15 3 times. 14 on top, 21 on bottom. 7 goes into both. 7 goes into this twice. 7 goes into this 3 times. So you see how we kind of cleaned everything up before we made a mess? Aha. So what are we left with? We're left with a minus sign. 2 times a 2 is a 4. 3 times a 3 is a 9. 420. 420, man. Oh, let's see. New piece of paper. Okay. We having fun yet? I know I am. -4/9 divided by, oh gosh, 8 over 21. Font's a little small. A fraction divided by a fraction. So the first thing I do is I rewrite it as -4/9. So remember, division is multiplication by the reciprocal. Oh my gosh, that was so long ago. So this guy stays the same. The bottom guy you flip. Okay. And then we'll do that same trick we did on 418. You could just multiply straight across, and then reduce. But that's just wasting time. Try and be as efficient, lazy, as possible. Does anything reduce before we multiply? Yeah, that 4 and the 8. They're both divisible by 4. 4 goes in once, 4 goes in twice. 9 and 21, can we reduce it? What goes into them? 3. 3 goes in here 7 times, 3 goes in here 3 times. Anything else reduce? No? Okay. So I guess that's as good as it gets, because you can keep reducing anything upstairs with anything downstairs. So a negative, a 1, and a 7, multiply it all. -7 over 3 times 2, 6. Boom. Okay. 422. 11 over 36 minus 15 over 48. Oh, fractions, I need a common denominator. Oh, wait, this guy reduces. So you're always trying to save time. So before I jump into a common denominator between 36 and 48, I noticed that 15 and 48 reduce because I know 3 goes into 15, and I also know that 3 goes into 48 because 4 plus 8 is 12, 3 goes into 12. Okay, so 11 over 36 minus calculator, 3 goes into here 5 times, 3 goes into here, 48 divided by 3 on calculator, 16. Does it reduce more? No. Okay, common denominator between 36 and 16. Oh my gosh, 36 and 16. I was doing so well. 36, 16. 36 is 4 times 9, which is 2 times 2, which is 3 times 3. 16 is 4 times 4, which is 2 times 2, which is 2 times 2. So we have a 2 squared and a 3 squared. We have a 2 to the 4th. Okay, so what do these both go into? I see some 2 stuff, I see some 3 stuff, and you just got to take the biggest. So the lowest common denominator is going to be, so I see some 2 stuff, I see a 2 squared, I see a 2 to the 4th. We're going to have to take the biggest, 2 to the 4th. I see some 3 to the 2, I see some not 3 stuff, take the biggest, times 3 squared. So that's going to be 2 to the 4th is, on your calculator, 2 to the 4th is 16 times 9, 16 times 9 is, LCD is 144. Okay, so that's our common denominator, 144. This right here drives people insane, and I hears ya. Let me see if I can, are we looking at the paper? Yes. Okay, so some people have a different approach. They would just do 16 times 2, 16 times 3, 16 times 4, 16 times 5, 16 times 6, and they keep doing every multiple of 16 all the way down the page, and then they do every multiple of 36 all the way down the page, so it's kind of inefficient, and then eventually you go, oh, they both have 144. Could I do that right now and waste time? Oh my gosh. Let's see. 16, 36. So 16 times 2 is 32. 16 times 3 is 48. 16 times 4, 64. 16 times 5, 80. You're probably just going to fast forward through this. 16 times 6, like I want to do, 96. 16 times 7. See how inefficient this is? 112. 16 times 8. 128. OMGs. OMGs. 16 times 9 is 144. And I keep going. Okay, 36. 36 times 2, 72. 36 times 3, 108. 36 times 4, 144. Oh, we got something to finally match. Oh, that's what a lowest common denominator is? Ugh, that's a pain. I guess if I factor things and then play the game over here, I guess it would save me time, although I really don't enjoy that. Yeah, I know. So, you do your factors, and then you say, okay, I see some 2 stuff, and I see some 3 stuff. Okay, 2 to the squared, 2 to the 4th, take the biggest. 3 squared and nothing, take the biggest, 3 squared. Okay, cool, boom. So, 144 minus world's longest problem? Maybe, 144. How did 36 become a 144? I had to multiply it by 4. So that means I have to multiply the top by 4, multiply the bottom by 4, multiply the top by 4. How did a 16 become 144? 144 divided by 16, 9. I had to multiply by 9. So if I multiply the bottoms by 9, I got to multiply the top by 9. 9 times 5, 45. Okay, so now the bottoms are the same. So you could just say 44 minus 45 all over that common denominator, 144, which gives us the 44 minus 45 is negative 1 all over 144. OMGs. Ta-da! Smiley face, world's longest problem. Okay, that's 422. Did anyone actually watch the whole thing? No? Okay. 420, was it on there? Yeah, it's good. Okay. 424. What am I done? Oh my gosh. That was 422, 424. I should have done every other even. Maybe I'll switch to that. Lazy. 424. This is a little inefficient what I'm doing. I'll start getting lazy. I'll just do part A. Negative 3y over 10 minus 5 over 6. Okay, so again, we need a common denominator. Does anything reduce? No. Common denominator between a 10 and a 6? What number do 10 and 6 both go into? 60. True, that works. Is there anything smaller? 30. Aha. So with practice, you eventually start to, if the numbers are small enough, you can kind of eyeball it. If the numbers are ugly, then you got to do what we did in 422. So I quickly recognize that 30 is going to be the lowest common denominator. How did 10 go into 30? How did 10 turn into 30? I had to multiply by 3. So multiply this guy by 3. Negative 9y. How did 6 turn into 30? I had to multiply by 5. So multiply this guy by 5. 25. Aha. So they all have the common denominator of 30. And what's left over? A negative 9y minus 25. Negative 9y minus 25. Okay. We're going to skip part B, go to 426. Oh my gosh. 4, 7 minus 3 minus 2, 4 minus 9, all over negative 3, 4 plus 2 plus 7, 3 minus 6. Okay. Parentheses. 7 minus 3 is a 4. 4 minus 9 is a negative 5. 4 plus 2 is 6. 3 minus 6 is a negative 3. Okay, so I'm going to try and clean things up. So 4 times 4 is 16. Minus 2 times minus 5 is a positive 10. Downstairs, a negative 3 times a 6 is a negative 18. And a 7 times a negative 3 is negative 21. Aha! So the top, 16 plus 10 is 26, and on bottom, a negative 18 and a negative 21. Negative 18 minus 21, enter. Negative 39. Okay. Oh, not allowed to leave negatives downstairs, so we clean it up a little bit. We say negative 26 over 39. We just moved the negative from downstairs to upstairs. It's just bad manners to leave a negative downstairs. Okay, are we done? Well, ask yourself, can it reduce? That's even, that's not, so 2 is not going to work. Does 3 go into this? 6 plus 2 is 8. 3 does not go into 8. So 3 doesn't go into the top. 3 goes into the bottom, but it has to go into both. 2, 13. Oh my gosh. Oh my gosh. 13 goes into both. 26 is 2 times 13. And 39 is 3 times 13. OMGs, OMGs. So divide by 13, you get a negative 2. Divide by 13, you get a 3. How did I see the 13? Ugh. I guess you just keep doing your homework enough and you start recognizing things. So tricky, 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 tricky. 428. Is there enough room down here? We shall find out. 428. They want you to figure out 4x squared y squared when x is 2/3 and when y is equal to negative 3/4. Oh my gosh. Oh my gosh. Okay, so that's going to be 4x, they said, is 2/3 squared. And then the y squared, and y is negative 3/4. Okay, so that's 4. Put the 4 over 1. There's stuff upstairs, there's stuff downstairs. So 4 over 1, 2/3 squared. So the little 2 is talking to each of them. It's talking to the 2 and to the 3. So that's going to give us a 4. 2 squared is 4, and 3 squared is 9. Negative squared, negative times negative is going to go to positive. So I'm just going to make the negative disappear. 3 squared is 9. 4 squared is 16. Okay, now notice, don't just multiply straight across. That'll work. It's just going to take a lot of time. You see how there's a 9 upstairs, 9 downstairs? Bye. Oh, what's 4 times 4? 16, and there's a 16 down there. So both of those combine to give us 16, and they cancel that guy. Bye-bye. Oh, everything disappeared. So the answer is nothing? No. Technically, you're always multiplying by 1, and there's a 1 downstairs. So we technically have 1 over 1, which we just call 1. Aha. Let's see, 430. 430. We have the number 6.738. Round to the nearest hundredth, the hundredth. So remember, we have the tenths, the hundredths, the thousandths. There is no ones place. So the first location after the decimals, tenths, hundredths, thousandths. A, round to the nearest hundredths. So point at the hundredths place. There's a 3 there. Look next door to the right. Is it 5 or more? Yes. So round him up. 6.74. B, round to the tenths place. Point at the tenths place. The original problem. There's a 7. Look next door to the right. Is it 5 or more? No. So leave them alone. 6.7. C, round to the nearest whole number. Okay. So for the whole number, you basically point at this location right here, the whole number, the ones place. Look next door to the right. Is it 5 or more? Yeah. So round him up. Should I put little things like that for my 7s? Look prettier. Okay. Whole number. Point at the whole number. Look next door to the right. Is it 5 or more? Yes. So round up. Okay. 432. Perform the indicated. Okay, just throw that in your calculator. 434. Calculator. 36. So 432 to 438. I mean, those are just calculators. Throw it into your calculator. Okay, 440 now. Am I getting lazy? 440. I just feel like you can handle those. Just throw them in your calculator, no big deal. 440. Write each decimal as a fraction. So 0.65, write it as a fraction. So there's 2 places beyond the decimal. So this is just 65 over 100. That seems good. I'm not sure if they reduce it, but if they do reduce it, so I'd be happy with that, but let's just reduce it. 5 goes into both, so let's see, 65 divided by 5 is 13, and 100 divided by 5 is 20. So I would go to the back of the book. I don't want to scroll to the back of the book right now because it'd be too complicated for me. So I would write down both of them, go to the back of the book. Oh, which one did they have? Okay, cool. 4, 4, 2. Convert each fraction to a decimal. Negative 5/8 is negative, so calculator 5 divided by 8. Enter. Negative 0.625. Okay, calculator. Easy. 4, 4, 4. Convert each decimal to a percent. Okay, 2.43. Convert 444. Convert each decimal to a percent. Okay, so to go to a percent, 2.43, I'm going to move the decimal 2 places over. So 243%. 243%. So just remember a couple things that always make sense to me is 1 is equal to 100%. So you see how the 1, if I move it the decimal 2 places over, I get 100%. So this one makes sense now. Okay, cool. 446. Square root of 289. Just make sure you're cool with your calculator. Square root of 289 is 17. I just have that one memorized. Math teacher. 448. Whole number, integer, rational, irrational, real numbers. 448. Let's see. Ooh, 448. Oh, they didn't have one for you to do. Oh well. So 448. Let's see. -8. It's an integer because it's negative. 0 is a whole number? Do whole numbers include 0? I'm a math teacher. I'll put a question mark. I mean, it's technically an integer. In the following, list the whole numbers. Okay. Well, it's definitely an integer. Is it also a whole number? Do whole numbers include 0? The natural numbers, the whole numbers. I'll say it's a whole number also. I might have to put a little note after this video. How is it that I don't know these things? I guess because it doesn't matter? Okay. Then you have a number like 1.95286, ... You see how it's not repeating? If it's not repeating, we can say that's irrational. 12 over 5. That's fine. 12 over 5. If you put in your calculator, it'll eventually just stop, right? It doesn't keep repeating forever and ever, so this is just rational. 12 over 5. Square root of 36. That's just 6. So 6 is a whole number, which is also an integer. And then 9 is just a whole number, which is also an integer. I guess technically it's a rational number because you could think of it as 9 over 1. So 448. So I guess it's technically an integer also. I don't like problems like that. Just be able to recognize an irrational number. They don't repeat. And rational numbers are just nice fractions. Okay. Well, that was a bad explanation. But we're going to move on. I might put a little note clarifying that. But we need to do algebra, not get stuck on what things are called. I locate these on the number line. 450. You have a number line. You have 0, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3 backwards, -1, -2, -3. So where's 3.2? It's between 3 and 4. It's like right there. So right there is 3.2. Where is -1.35? Here's -1, here's -2, so -1.35 is about right there. -1.35. Okay, number line. That was 450. Ooh, I'll take a little break right here. Okay. We're doing good, right?